It's called the fundamental theorem of calculus. And we'll be abbreviating it FTC, and occasionally I'll put in a 1 here because there will be 2 versions of it, but this is the one that you'll be using the most in this class. The fundamental theorem of calculus says the following. It says that if f prime is equal to f, so f prime of x is equal to little f of x, is a capital F and a little f, then the integral from a to b of f of x is equal to f of b minus f of a. That's it. That's the whole theorem. And you may recognize it. Before we had the notation that f was the antiderivative. That is, capital F was the integral of f of x. We wrote it this way. And this is this indefinite integral. And now we're putting in definite values. And we have a connection between the 2 uses of the integral sign. But with the definite values, we get real numbers out instead of a function, or a function up to a constant. So this is it. This is the formula. And it's usually also written with another notation. So I want to introduce that notation to you as well. So there's a new notation here, which you'll find very convenient because we don't always have to give a letter F to the functions involved. So it's an abbreviation. For right now, there will be a lot of F's. But anyway, so here's the abbreviation. Whenever I have a difference between a function at 2 values, I also can write this as f of x with an a down here and a b up there. So that's the notation that we use. And you can also, for emphasis, and this sometimes turns out to be important when there's more than one variable floating around in the problem, to specify that the variable is x. So this is the same thing as x equals a and x equals b. It indicates where you want to plug in, what you want to plug in. And now you take the top value minus the bottom value. So f of b minus f of a. So this is just a notation. And in that notation, of course, the theorem can be written as with this set of symbols here equally well.